I think we're ready to go, gentlemen. Hello, once again, everybody. Your South Coast Longtime Astronomy and Telescope Club, our beloved Santa Barbara Astronomical Unit, now convenes and present our weekly Monday morning blog podcast from our man caves, and computer dens. It's the SBAU Astro Hour, everybody. Viewable on YouTube, featuring the Big Bad Brain Trust of Santa Barbara's Astronomical Unit. And these guys on the board are some pretty knowledgeable gents. I'm Ron Heron, Vice President, and proud to be, and I'll introduce you to the board in a minute. This hour, we're going to try to talk to the world about Draco the Dragon and the Little Dipper, possibly Lyra and the Ring Nebula. Saturn is in opposition, if you're going to go check it out. We're going to talk about a couple of her moons. We got a full moon. It's waxing full by this week, and it'll probably drown out the Perseid meteor shower. We'll talk about that. And what about the Fermi paradox? Whatever happened to that? And there's a new rare earth hypothesis that's got me all kind of excited in a Twitter. And two of our own are going to talk about the web on the 2nd of September for our next general meeting, possibly online. Let's meet the guys. Jerry Wilson, president. How many years now? 4?
I think 5.
All right, we're going to be the Vladimir Putin of astronomy clubs. Nobody else is running. I don't know what the hell I'm doing in here as vice president. Jerry is president. He's married to Pat Forgy, and the outreach coordinator, Chuck McPartland, in front of the Ukraine flag, is also married to Pat, our merchandise manager. We have joining us early on today, Bruce Burdock, longtime active member, Bruce.
Hello.
And, he's an incredible, operator of a telescope. You show up at a lot of our second Saturday star parties, including one, I guess, next week. And he also is president of the Santa Barbara Theater Organ Society, married to Bonnie, right?
Right, Bonnie. Yeah, I've been president of the Theater Organ Society for over 20 years.
Well, let's get everybody back up and running. Get those damn masks off. Tom Whittemore is our sourdough bread baking, former Westmont College science instructor and editor of our newspaper. Our newsletter comes online every month. Life is Maureen. And sense of humor comes with everybody, but somehow our beloved president sends us these silly, I call them silly science cartoons. They're mostly science, and there were a total of 6. Some of them have astronomy as a topic, but we'll share a few of them. Whatever you call up, I'll see if I can match what I've noted about them, Jerry.
Okay.
You enjoy sending these out on your phone, your iPhone, your smartphone.
Yeah.
I don't know how you do that.
Yeah, I can't seem to get that to center on that. Well, so
I get my inbox now on my phone for the first time, but I don't play. Here we go. Carbon dating. If you've ever wondered about carbon dating, first date. Here we go. The big lump of coal sits across from a diamond, says to the gem, his date, "You look older than your profile picture," to which the diamond replies, "Well, I've been under a lot of pressure lately, for crying out loud." Never understand how that happens. Okay, this one's, oh yeah. It's the literary landscape. No, that's the windmill. Stream of consciousness. Well, let me just look at it. Sir, the Curiosity rover is stuck on something. It's sitting here in the JPL. No idea what it is, and it shows it having run over. Is that a person?
it's Marvin the Martian from the Warner Brothers cartoons.
Oh, it's the
Bugs Bunny cartoons.
Okay. Okay. I love it when you just, all right, here we go. This one I kind of like. Literally,
I like that one.
Yeah. A shot of a distant windmill with a road sign in the foreground depicting a total no-no ban on any man of La Mancha who might want to assault the blades on a horse with a lance. Ta, 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 ta. What is the song that comes to mind for that? To dream the impossible dream.
That's right, that's it.
Yeah, all right.
Dulcinea.
These these are different versions.
These are useful metaphors.
Would you like to guide us through that?
Well, on the left, we have the font of all knowledge.
Okay.
Then we have the tap of occasional insight. Then there's a bucket of useless trivia. My dad used to refer to things like that as a little known fact hardly worth knowing. And there's the sprinkler of dubious facts spotted here and there, sort of a dilettante. And then the puddle of misleading statistics.
Man,
Now that's all I have. You said 6, I only had 4 here.
well, there's 5 there, and
Oh, was it 5? Okay.
yeah, there were 5. But I heard today that government's going to give up on Lake Mead. There's not much they can do. They're going to write it off and get water somehow. Is
Yeah.
that
Well,
all
it
you
also
got?
gets to the point that as the water level in Lake Mead gets low and it's almost there, that they no longer will be able to generate electricity.
Well, that's true. Yeah, those intake towers are above the water line. They keep finding
No,
bodies.
it's not that. They need a certain head of water, a certain water pressure
Yeah.
to run the turbines, to run the generators. And when the lake gets too low, that doesn't work.
Yeah, the water has an energy in it from falling from a height h, mass height times the gravitational constant, mgh. And when the h gets too low, there's not enough energy to turn the turbines. And
Wow.
the h is getting way down there, close to 0.
It's
Well,
only about, I don't know, 10 feet or something above that level.
Yeah.
If they could pipe oil all the way across Alaska, why can't we get the Great Lakes water piped across America to the west?
There's easier ways to get water. I mean, the Gulf of Mexico is right there, and they just need to desal it. That's expensive water. We're not running out of water. We're running out of cheap water that you dig out of the ground and use. We're going to have to start processing water by making it into drinking water.
Well, I challenge you, Mr. President, to make that a topic some Monday morning.
Well, that's not really an astronomy thing. It's an engineering thing, but
It's
we can,
definitely
we can consider it.
it's a factor.
Okay.
You want to go chronologically from the beginning of your talking points? This is episode number 76, incidentally. We've been on the air a long time. The Dragon After Dark. Tonight, Draco curls itself around Little Dipper to the north. And I just learned something from your notes I didn't know. The star pattern is the 8th largest of the 88 constellations, covering 1,083 square degrees. I've never imagined. It's about 3% of the sky. And it's home to the magnitude 4 star Thuban. Used to be the North Star. Sits
Thuban is right there.
Yep. I'll let you take over. It used to be our North Pole star, our
Oh, no,
Polaris.
you're doing great.
And Vega is going to be the North Star someday. We won't be around, but okay. Give us a tour here of the sky, Jerry.
Yep. Hey, Jerry.
Yeah.
Yeah, if I might add something. So,
Go ahead.
oh yeah, I like to teach Draco from the point of view of the two dippers. So the way I have people look at Draco the dragon is to first find 2 dippers, okay, and then basically the lower extremities of the dragon is always in between the 2 dippers, okay, and then it rolls over the Little Dipper, okay. There you go. And I did this at the last outreach at Westmont, the July outreach, and I was out. In my opinion, people were not masking up well. I was out on the deck with folks, and using my green laser pointer, I showed them Draco and how easy it is to find it this way.
Mhm.
So that's my 2 cents.
Okay. And then up here is this loop of the dragon's head.
Mm-hmm.
And what did they call it? The biscuit or something?
The lozenge.
The lozenge, that's right. So I guess that the circlet of stars was used elsewhere in the sky twice, and so they didn't call this the circlet of Draco.
Calling from Dr. Wu.
Be nice to see the dragon as it looks, but that's all right. I'll imagine. Most of the constellations are animals, aren't they? With legs.
Well, Southern Hemisphere has a lot of pumps and
Yeah.
printing
Yeah.
presses.
Yeah. A lot of devices, huh, Chuck?
Okay, thank
Yeah.
you. I'm having problem with the refraction.
So yeah, to just get to that point, Ron.
Get to what?
Zodiac basically means, life, animals. And so most of the things in the Zodiac are also animals.
Was Zodiac one of the first things that came up? I know it's part of astrology, but it's also a part of astronomy as far as locating places on the ecliptic. And
astrology was first, and it's based on belief systems and complete misunderstanding of what's going on. But it was attributed things to, it was an anthropomorphic view of things. And we inherited, astronomy grew out of astrology, and we added knowledge to it, and now they've separated completely. The same way as chemistry has split from alchemy, where they're mixing all these random things together to try and figure out how to make gold.
And they're managing to do some things today, aren't they, with modern chemical methods and colliders and things like that. They turn gold in, or they turn things into gold, don't they? There is a way to do that. Radio.
Well, you can turn things into gold. Yeah. Bruce, can you unmute yourself?
Say again?
Can you unmute yourself?
Oh, yeah. Does that mean mute? Turn it off or turn it off?
He is muted.
Yeah.
Here he goes.
Now we can hear him again.
No, I'm not muted. Yeah, my phone rang and I couldn't find the mute button on it.
That's okay.
That's okay. We're in the middle of the asterism lozenge. That's a lot to swallow, gentlemen, that one.
Okay.
4 stars that outline it: Draco's Head, Rastaban, Eltonin, Grumium, and Alracus. You guys know those, don't you?
Oh, yeah.
This is not a terribly bright constellation. It's not one that will jump out at you. You have to look for it.
Yeah.
Where I am, we can see at about 75 feet above sea level. I can see Big Dipper relatively easily. I can see the brighter parts of the Little Dipper and the Pole Star, but it takes a clearer night than I frequently get to see the rest of the Little Dipper stand out. And when I take pictures at night, I have to be able to see the Little Dipper very clearly in order to be worthwhile taking pictures.
And I think we've already established the Little Dipper is not the Pleiades.
No, although to some people with very good eye, the Pleiades does look like a teeny dipper.
I always thought it was a great 1-star handle, because
Yeah.
I can only see 5 stars in the Little Dipper or in the Pleiades. There's a lot more up there. That's fascinating stuff. Okay.
Generally, 7 are pretty easy to see, but I think there's like 14 or 21 or a big number or dimmer.
Yeah, if you get a telescope, you really can see a lot.
Oh, yeah.
And Jerry points out in his notes that beautiful double up there, New Draconis. It's really pretty in the small scope. Very pretty.
Has anybody ever listed all the asterisms? Are there more of those than there are constellations? We've got a new one, lozenge here.
Probably.
Each constellation is an asterism, and then they have asterisms within them. So
Anything that tweaks your interest or you remember a pattern, that's an asterism for you.
Yeah.
There's no official tally of asterisms.
Well, except the word lozenge, we certainly know what that means today, but I wonder if it has an ancient meaning or an old.
In preparing these talking points, that's the first time I've ever heard it referred to.
Okay.
And so, Ron, I've got a task for you.
Okay.
Tonight, go out and find the closest thing you can to your face with a beret on top. And you can call it a Ron asterism.
I could put together any combinations of stars just about the way they do it, and draw something around
Oh,
them.
yeah, no.
Yeah, that's funny.
I pointed out some time ago, we had the bull Poniatowski, used to be a constellation, now it's just an asterism, so they move back and forth a lot,
Yeah, well, I just learned the asterism thing from this show, Jenna. Are we close to Lyra and the Ring Nebula, or shall we go to the waxing moon and the Perseids?
No, the Ring Nebula is up these days. See if I can get it.
Okay, here we go. There's the old ring. Oh, you missed it.
No, that's not the right thing for that.
There we are.
Yeah.
Aha.
That is the Ring Nebula. Oh, I know what I was looking for a star chart. It's not a star chart. It's there. Whoops. This is a picture of Lyra.
Oh,
And this is Vega.
Mhm.
There is a, who knows the name of this particular geometric?
Parallelogram.
Yes,
Yeah.
parallel.
And so and it's one of the easiest things to spot because it's right near a very bright star, a star that defines zero magnitude,
Mhm.
used to. And then this little pattern really stands out because it's not a random, the human eye will pick this pattern out. And right here, between these two stars, right in there, is the Ring Nebula.
really? There's a whole nebula in there and we don't see it, really?
It's one of the easiest things to find.
Mhm.
This is what it looks like in Hubble. This star in the center is a 14th magnitude star, white dwarf. And this is a planetary nebula that where it blew off, it's not the result of a nova. It's the end game of a star like our sun.
Mhm.
This is highly magnified. And when you see this in your small amateur telescopes, which usually run about 30 power when you're first looking through them, this is quite hard to spot. It looks like a little fat star. And you have to know what you're looking for in order to blow it up and magnify it, to see the ringness.
And I think Chuck has a name for it too, don't you, Chuck?
It's a powdered donut.
Yeah. By the way, this was when I was a kid, my brother Paul borrowed a 6-inch telescope. It was homemade. And in Indianapolis, at the time as a kid, the skies were fairly dark. They're not anymore. But this was one of the first objects that Paul ever showed me, and it probably is responsible for my interest in astronomy.
Well, are we looking at a flat egg like a galaxy, or is it a round egg?
No, it's more like it's an hourglass shape.
Yeah.
We're looking at it end on.
And from the top or bottom, in other words, looking up? How would they know that?
They can see different parts of it have different recession and approach velocities with the Hubble taking a spectrum.
Mhm.
Wow. And
And look at the
Vega,
star-studded field, Ron.
Yeah.
Look at that beautiful field.
This is right next to, well, anyway, this is Vega again. The purpose of this picture, why it's not a star chart or finder chart, is this red star right here, which is a carbon star. It's T Lyrae.
Okay.
And these are dramatically red stars.
Yeah. So the star T would mean RST. It would be the third named carbon-like variable star in Lyra.
what does that mean? It has more carbon than any other element?
It has carbon in its outer atmosphere. In molecular form even, it's so cool, and that absorbs blue light.
Yeah, so it looks very red.
And it happens to be the brightest of all the stars, not brighter than Venus, but Venus is not a star, so.
Oh, Vega?
Yeah. And it's going to be our North Star someday. Is that correct?
No, there are stars. Vega's not the brightest star. Sirius is the brightest star in our sky, in the northern hemisphere.
And the brightest one up right now is Arcturus, just slightly brighter than Vega.
Yeah.
And very pretty red.
And those 4 stars to the lower right of it, that's called the parallelogram.
Of Lyra.
It sure looks like one. Almost looks like the 3 stars in a row in Orion's belt that are not exactly in a straight line, are they? One's a little off.
Yeah. And also, Ron, the star that's below Vega and to the left also belongs to Lyra. Lyra, the harp. It's a harp, by the way, a harp.
And that's the double-double.
That's it. That is it.
Okay, well, how do you pronounce Lyrae? Lyrae? Lyrae?
Hooray.
Lyrae.
In Latin, it's Lyrae of Lyra.
Okay.
Possessive case.
Now, when Charles Messier discovered the
Chuck
Ring
Messier.
Nebula, what's that?
Chuck Messier. I like
Chuck
that.
Messier, yeah.
Chuck, yeah.
So when he discovered it, he described it as as large as Jupiter and resembles a planet which is fading. That's what he saw for the Lee Nebula, and that's what probably started calling these things planetary nebulas, because they look like planets. Has no relationship.
Another effect was that, in the mid 1800s, by then they'd discovered Uranus and Neptune, which look greenish, and a lot of the planetaries have a lot of oxygen, ionized oxygen emission, which is green.
Huh. And the definition of a nebula, a star making a cloud.
Cloud, literally cloud. Yeah.
Latin for cloud.
And it's often a expended star that blew up, form a nova, supernova.
No nova.
No
A nova is kind of a different thing, but yeah, supernova will leave a remnant.
Okay.
Okay, now this is a star chart of Lyra. This is the parallelogram.
Oh, is it in there? Where is it?
Over here, Vega, M57 right there. Next to it is another geometric figure, easy to spot, is Hercules. And this feature here is called the keystone. And up on the side away from Lyra, 1/3 of the way down is M13, which is one of the prettiest globular clusters in the sky. And this is another easy one to find. And this is M13.
And nicely high overhead right now.
Yeah, these are good night sky objects, evening sky objects.
Yeah, as Jerry points out that there's 6207 up on the top there. It's a distant galaxy. It's really fun to see. There.
Yeah, right up there.
Now, is that star cluster the one where in the center you have like 3 times 3 times 3 light years on a side, and there's 100 stars within a cube?
Yep.
That's one.
That's about right.
Wow. That would mean the average distance between the stars would be light months.
Yeah.
Weeks.
Not too many astronomers living there.
Yeah. Hey, Jerry, would you mind?
Evolution experts.
Yeah.
Yes.
Would you mind just going back to the keystone, please? I'll just make a comment.
I think I know what a keystone is. You want to answer that, Bruce?
Okay. So in the keystone.
Hello, Owen. I'm on Talk Radio Show. I'll call you back.
Call the specs. Solar system is headed that direction.
You really broke up, Tom.
Oh, I did? I'm sorry.
Yeah.
Did you guys hear the keystone contains what's called the solar apex? Can you hear me now?
Yes.
Oh, okay. Okay. And the solar apex is the direction in the night sky where we're being dragged towards with our, motion and in the galaxy. So the solar system is being dragged there by our sun in that general direction, the solar apex. And
I think it was Halley that first got a hint of that.
Yeah. And opposite that, and I can't remember the constellation, maybe you do too, Chuck, is the apex. In other words, the one we're going away from. Okay. So this is the solar apex, and 180 degrees away would be the apex, where we're going away.
Now we're talking about a 3-star triangular shaped, named after a part of an archway, isn't it?
It's a quadrilateral. It's not 3 stars, it's 4.
There's 4 stars there, Ron. Yeah.
Okay, I only see 3. 1, 2, 3.
There's a little dim one right there. Jerry got it.
But am I right? Is a keystone part of the building of an arch?
It's the top stone, the last one set in.
Yeah, the one that the arch work, Ron.
Yeah.
Never understood how those things stay up and don't collapse.
Well, you can see how it's canted. See how it's pitched? You can imagine, a half of a ring on the right and a half of a ring on the left. And so that thing just anchors. It anchors the archway.
Wow.
The antepex, I just
ahead.
quickly looked. The antepex is in Columba, the dove.
Okay, thanks a lot. I knew we couldn't see. Oh, we can see Columba here. I do see it in the southern sky here. Yeah. Thanks, Chuck.
Mr. President, these sky charts come through the magazine you post?
No.
Oh,
No,
no, I
these are
get these
good
from
ones.
Oh,
These are good charts. You can tell the ones that come from Astronomy Magazine because they're almost impossible to decipher.
these come from a planetarium program that I use to steer my telescope from my computer.
Okay.
On this chart, if I pick a star, for example, go here, and if I highlight, I can't do this now because it's an image, but if I'm in the program, I would pick the star like the one where my cursor is, and then I would go up and press the slew button, and my telescope would slew to that position and center on the star if I've aligned everything.
I see.
So these are very useful. Well, let's go to the where are the Fermi paradox?
Oh, listen, that's got me going. Let me tell you, this is originally named for Enrico Fermi, right? He came up with the postulated, where the heck are the intelligent aliens, that are out there?
Now, someone asked him in the 30s if he believed in, if he thought there was extraterrestrial life out there that was intelligent. And he says, if they're there, where are they? Why haven't we seen them? And that's been called the Fermi paradox ever since.
Well, there's also, before we get into the new version here, the new hypothesis, what's that formula with all the N's in a row?
Drake.
The Drake equation.
Drake equation. And these two new guys, researchers Peter Ward and Donald Brownlee, came up with this rare earth hypothesis that seems to make a lot of sense to me. I'm sorry to say, most people want the aliens to be out there.
Yeah.
Too many.
Well, I want them to be out there too, but I've often thought along the lines of their new book, and this is actually an article from Astronomy Magazine that was published. When was it? July 29 of this year.
Mm-hmm.
So they've been trying to figure out. There's a lot of options for why we don't see them. One of them is that they know we're here, but they just want to observe us. Well, I forget the other one. There are 3 or 4 competing ones, but I've always felt that this one, even though I haven't read an articulation of it, I've always suspected something like this. So many things have happened to the Earth, and maybe all of them are required for the development of advanced life. I think that as they conclude in their book here, the guys are, who are the guys?
Peter Ward and Donald Brownlee.
Yeah, Brownlee, yeah. As they include in there, their argument does not apply to bacterial life, to low forms of life. Because those forms of life live in so many hostile places. A very wide range of things can be tolerated by them. But to get to be highly developed, what do they call us?
Yeah, their definition of advanced life is basically just multicellular life.
Right, to get to be that requires a very, very narrow, strict, and improbable line of events. And he articulates the events. So
the name of the book is Rare Earth, Why Complex Life is Uncommon in the Universe.
Yeah, he has 12 things that the Earth has done. And if all 12 of them are required, then it's easy to see that intelligent life is extremely rare in the universe. Not impossible, but improbable.
Right. But when you look at the number of planets we're finding and the number of, in our galaxy and the number of galaxies we're finding just in what we can see, even the improbable, is probably out there.
Yeah, that's good old Murphy's Law.
Yeah.
No matter how low the probability, if it's possible, it's going to happen. Well, it did happen. It happened here.
Yeah.
It probably happened somewhere else too, but probably not within a distance that's going to be easy for us to get to or even to know about.
Yeah.
I'll tell you this. Go ahead, gentlemen.
And it's not clear that being a technological society is a good thing, evolutionary wise, because we're working really hard on killing ourselves and a lot of stuff around us.
Yeah,
Yes.
we're balancing on a knife edge for sure.
The old Darwinian survival of the fittest. You can't go away from that. But I have encapsulized or shortened these 12 if you want me to run through them real fast.
Go ahead.
Planet should be the number one. The planet should be in a good part of the galaxy. should be orbiting for a very long time. The star should be a long running one like ours, 4 billion years. Liquid water, far enough from the star not to become tidally locked, has a stable orbit, meaning mostly circular like we do. Planet should tilt for the seasons. Distant gas giants should be in the system to clean up the rocks, and big enough to have an atmosphere and oceans. It's got to have a moon big enough to stabilize our axis. Has to have a molten core to produce magnetic field. Has to have oxygen in the right amount and be replenished. And plate tectonics that builds up the land masses, creates diverse ecosystems, cycles the carbon into and out of the atmosphere, prevents the runaway greenhouse effect, and stables the worldwide temperature.
And we have a great example right next door to us of a planet that meets almost all those criteria, but not enough of them. Apparently does not have plate tectonics to recycle the atmosphere and the ground. And that has endured just being a little off from us in some of these features, a runaway greenhouse effect. And life there as we know it is not possible.
And that's another thing. That list presupposes life as we know it, you know,
Yes,
with a
yes,
water-based sort of chemistry.
Yeah.
Did you tell us, Jerry, what planet was it? Mars or Venus or Proxima Centauri?
Venus.
Yeah,
Both
Venus.
of those.
Is Venus in the habitable zone, the Goldilocks?
It's close to it.
Yeah.
And it was in the Goldilocks zone. I guess our sun is heating up slightly. Is that the case?
It's gone through phase where it was hotter in the past, when it was young,
Yeah.
and now it's gradually heating up over the next, 800 million years or so. But
Well, has anybody compared these 12 notes of the two guys to the Drake formula? How many conditions are
Well,
like?
this is sort of orthogonal to the Drake formula. The Drake formula is life itself. It's advanced stuff too.
this is the last couple of terms of the Drake equation.
Yeah.
I'm trying to find an equation for that.
Yeah.
There's only about 7 or 8 or 9 items in the Drake. This has got 12. So they came up with some new conditions, didn't they?
And some of those, I don't know that they're an absolute necessity, because if you were well enough placed in the Goldilocks zone and rotated at the right rate, you wouldn't need seasons necessarily.
Huh. Well, it's pretty much like that on the Earth right now in the tropical equatorial part.
Right.
Seasons. I have a feeling in the future with global warming, everything's going to move north and south.
There's no simple rule like that. We're going to be getting lots of changes, lots of extreme storms, lots of high temperatures, lots of low temperatures in storms.
Yeah, the effects are chaotic. You can't,
Yeah.
it's very hard to predict, other than that it's going to get really warm.
The point of it is that we have had a long period where human civilization has developed, where things are fairly stable. That is, areas that can produce grains, and areas that can produce grapes for wine, produce grapes for wine. And now things are getting unstable, not only just in Ukraine from the war, but I mean from the climate. And areas that have been heavy producers of grains are not going to be able to reliably produce that. So the world, it's not that the earth is going to all of a sudden become this total death oven. It's that us sustaining the kind of civilization that we have with being able to feed everybody, that stuff is all going to become interrupted on a regular basis.
Being a home baker and everything, it turns out that where we can grow these grains, these wheats and things, is really moving. They're really moving, and it's because of the climate change.
Yeah. My fave is that the southern France is getting a little warm for the type of wine grapes they like to grow.
Yes.
And for the first time, wines that could only be produced in France are now being produced in England because the climate is changing.
Well, I've booked a vacation on a resort island up just off Greenland someday. Gonna lay out there in the sun.
Uh-huh.
Is Bruce still with us? I don't see him.
Yeah,
Okay.
I had a business call that came in, so I put it on mute and
Oh, that's okay. Do you want to comment on what we're talking about? What's your vision on other life, extraterrestrial intelligence?
I think it's absolute.
Absolutely.
You start going through, is the Drake equation. And there are more stars in the universe than there are grains of sand on the Earth in total.
I've heard that. So there might be good odds.
There may be planets around other stars that are in the habitable zone, but they've either blown themselves up or they haven't gotten to that point. How long have we been here in technological smartness? A couple hundred years. When did the Industrial Revolution start? That was the
Early
middle
1800s.
1800s, right?
Mm-hmm.
About
It
1700.
was all horsepower, literally with horses. And, manual labor in the field, tilling the fields. And then, the definition of an acre was the amount of land that a farmer could plow with his horse in a day.
Yeah.
So, when you're talking about billions of years of time for planets to evolve, and we're looking at a couple hundred year slice, what's the probability you'll get an overlap that there happens to be intelligent civilization on a planet that's in the habitable zone in the period of time that we're looking?
Yeah, that's one of the Drake equation variables is the length of time between turning on as a technical society and blowing themselves up. So for us, it's about 200 years, 300 years, as you point out. This schematic, we're tying back into the same topic, but this represents, of course, our solar system. And the fact that we have two large gas giants, particularly Jupiter in here, apparently is a big protector from the Earth, from catastrophic events.
Yeah, it sucks.
Yeah.
Well, it's kind of a mixed bag. It occasionally tosses stuff our way too.
But the operative word is occasional.
Yeah.
And how that is. This one is the what do they call the shepherd dogs of sheep flock? Sheepdog.
Shepherd.
This is the shepherd of our solar system.
Yeah.
Keeps all the little Trojans lined up and a lot of other things too. But every now and then it does fling something in, but it also captures a lot of it too. So
think of the summer of 1994, Jerry. It got pummeled.
Yeah.
It
took one for the team. It took about 8 for the team.
I think it was 21 total.
21.
Yeah.
Okay.
That's right. The head broke up.
But several million.
This illustrates one of the points, and that is that the Earth has a large moon, and whether or not we have tide tides, we have them. There is a hypothesis about developing of life in tide pools, so that we would need life for that, or moon for that. But the moon, the point is that the moon, if we need it, is unique to Earth. We don't have any other planet in our system that has a moon this big. And the source of the moon is fairly unique. That is, it's believed to have come, and it probably did, from a planetary collision early on. So, and it's hard to capture a moon because you need something else, a third body to carry away, to slow this object down and leave it around the Earth to get rid of some of its energy. So for us to have captured a large moon like this is very problematic. But we are away from all the other bodies we might capture, but we still have this large moon, and we didn't have to capture it. So these are all improbable things.
Well, except for the tides, what does it do for us?
It stabilizes the tilt of the axis somewhat.
Yeah.
Right.
Really? We'd wobble like crazy without a moon?
Yeah.
Oh, yes.
But,
Absolutely.
and the tides would become unpredictable and wash over the land.
Yeah, the moon creates the tides, which create friction, which is the damping force.
Huh, well, we wobble anyway, I understand. It's gonna get a little bit of,
We go through 25,000 year precession, not a wobble.
oh,
And that we alluded to that earlier when we talked about Thuban and Vega at times in the past and again in the future being our pole star.
There's also a slight nutation about that wobble too.
Yeah.
The axis wobbles too.
so
But
something,
all these things are slow and controllable, and they're not catastrophic sudden things.
Mhm, mhm.
most orbits are not round at all, are they? In fact, there's probably very few that are totally round.
Well, round is a special case of an ellipse.
Yeah.
They're all elliptical or conic sections.
I know, but if they're really conical, you go from extreme hot to extreme cold.
Oh, yeah.
Okay, so
Or you can, if the plane that's slicing the cone is vertical, it becomes a hyperbola.
Or
So-
parabola.
Parabola.
Or either one.
Yeah.
So whatever is going to come in only comes in once.
And goes out.
okay, but the theory is that what we're looking at now was a planet or something the size of Mars that collided with Earth billions of years ago, recollected itself into that moon, and somehow got into a pretty close round orbit. I think it's around 240 million miles, right? Or no,
40,000.
1,000 miles.
Well, the two objects colliding, as long as both of them are in an orbit around the sun, which they probably were, you're not going to get anything thrown into a wild or hyperbolic or parabolic orbit, or even a highly elliptical orbit. It's going to be pretty much the orbits like the orbit that they started with. The Theia, the thing that hit the Earth, is now part of the Earth and part of the moon, just as the Earth is.
Well, didn't they find that the moon has got a lot more granite in it than does the Earth? And it was
Granite?
pardon?
I haven't heard that. I had heard that it's like the mantle, the composition is like the mantle of the Earth or the surface. But
Okay, same, that's kind of the same point I was leading to.
okay,
And that was because the Theia, which crashed into basically what's now the Pacific Ocean, threw up a lot of the mantle and the upper crust, not the basalt and the iron that's down in the middle.
Right. The the idea is this large object collided and basically everything melted. I mean, there was a lot of energy dispersed. It's not like it just excavated out the Pacific Basin.
yeah,
And you had a large cloud of molten debris, basically, or vaporized debris in this sort of donutty shaped thing called a synestia that eventually parts coalesce to form multiple moons. We think we had up to 3 moons at one point of different sizes, but they were in very similar orbits. So their relative velocity relative to each other was less. And so most of the dense stuff like the iron ended up in the core of the Earth. So there's a much smaller iron core in proportion on the moon. And then one of these submoons, they eventually collided to form the moon we have now. One of these submoons basically coated what we see as the far side of the moon that you're seeing here with very few mares with that crustal material, the lighter sort of silicate stuff.
That's interesting, yeah.
Yeah.
That's why the center of mass of the moon is not in the middle.
Right.
no. The moon is orbiting us heavy side down.
Yeah.
Of course.
So possibly the ninth planet way back at the beginning crashed into the we're the third planet, and we got more of the stuff in the collision and less of it made a smaller body called the moon. And is that a possibility?
Yeah, but it was in an orbit like ours. It wasn't, flying in from outside somewhere.
Oh, okay. But all the rest of the debris formed either planets or in the middle.
Yeah, at the intersection where these two cars hit, they all stuck together.
Yeah.
Well, now, gentlemen, they found 5,000 or so exoplanets. Are they able to tell whether they have these 12 points going for any of them?
No,
Okay.
we're lucky to spot them with in in the Goldilocks zone, you see when when something's in the Goldilocks zone, it makes a big headline.
Yeah.
So we're very primitive on our ability to spot features and properties of exoplanets. That's what James Webb is going to do for us.
And I'm sure some of our speakers have told us this, but I've forgotten. How do they know? How will they know if there's life on a planet? Would they be able to tell?
Not absolutely certainly, I don't think, but there are some indications you can look for as like an atmosphere that's not in chemical equilibrium.
Or an atmosphere that features oxygen?
Yes.
Well, that's
One of the things.
oxygen's very reactive.
And they can tell if water is there?
Yeah.
Can water in the
But water's there in a lot of places. Water's on Jupiter.
Yeah, that's true. It is in the form of clouds. That's a fascinating picture. Is this a real picture?
Yep.
This was taken, I forget what the satellite was that took this.
Discover.
I think it's more recent than that, but I don't know. I don't recall.
Well, Discover is fairly recent.
Okay.
But obviously the photography satellite was way behind the moon looking toward us, both of us from behind.
See, the sun is at the back of the satellite, so both these things are front lit.
Really? So why don't we see the surface of the moon then?
We do see the surface.
The backside of the moon is very bland.
It is?
This is new moon.
Okay.
If we're on Earth, we see the face of the moon we usually see, but it's dark.
That would be, that would be a new moon to us, but what, I don't see any craters or Mare.
Well, no, that's
This is the far side of the moon, Ron.
Say that again, Chuck.
This is the far side of the moon.
Well, I know, but isn't it lit just like the Earth behind it?
Yes,
lit?
you can see it's lit there.
But it's very bland. It's very uniform.
You're confusing far side and dark side.
Pictures I used to see from some Soviet trawlers in space showed a really rugged landscape of nothing but craters. But
no, that's the near side. Well, this is a lot of craters, but no mare, no big seas.
Okay.
Just that one that you can see there, that's the Sea of Moscow.
Yeah.
Mm-hmm.
And somewhere there's a big crater called Soyakowski, but I don't know which one.
There's also a big mountain that's about the same height.
Looks like my lips,
6 miles.
Looks like liver spots. I'm sorry.
Well, this is just different contrast on this photograph than the Luna photo that you're thinking of the far side.
Yeah, that was close up. You're right.
This is actually a slice of liverwurst.
Yeah. Not chorizo like that Webb hoax thing.
Yeah, I saw that.
That was so funny. The guy put it up as a joke and said it was a joke. And then all of a sudden these people started, saying, well, he's trying to con us. So
Yeah.
it's just bullshit. People believe all sorts of things.
Do you know where he was? Just so we can set the stage for anybody that doesn't know about this. I just heard it this
I think he's down the street at the bar right now.
Yeah. I think he was a Frenchman or a Swiss.
Yeah.
He posted a slice of, what was it, liverwurst?
Chorizo.
Oh, chorizo. That's Mexican sausage, isn't it?
Yeah, it's a spicy, chunky sausage.
And called it a what? A moon or a?
He was just joking.
He said it was an image of Proxima Centauri.
Oh.
Yeah.
Well, I've seen the lit up Proxima. They think there's life on there, but I don't think it qualifies on many of these 12 steps.
Well, wait. Proxima is a star. Proxima is a red dwarf star.
Mm-hmm. Proxima Centauri. Okay.
Someday we'll get a picture of it.
Proxima B would be the planet?
Yes.
Oh, okay. Is there a Proxima A or is Proxima A the star?
Proxima A is the star.
Oh, I gotcha. Just like Sagittarius A is not really a star at all. It's the big, massive, black hole in the center of our galaxy.
It's a big A. Yeah.
So black holes are forms of stars that you can't see. Interesting.
And there's a lot of them. Some of them are small.
That's why I wondered about dark matter. Why can't it just be all the stuff we can't see that takes up all that gravity?
Because black holes interact with light and dark matter does not interact with light.
Well, you got to have light passing by it or through it, don't you, to know that it's there?
No, because you see gravitational effects from dark
Right.
matter.
You fly by and you start sticking to something and go, oh, what's that? I don't see anything.
Oh, we don't-
Presentation last Friday was very interesting on that, where the supersonic wind basically, or motion in the gas in
Hello.
space.
Yeah, the fact that the dark matter is essential for the condensation of galaxies and lumps, because the light interacts with baryonic matter differently than the dark matter does. And the dark matter can clump. It can resist the restraining force where baryonic matter can't.
Huh.
I guess I screwed that explanation up pretty good, but I was impressed with the talk.
But somehow thank you. Somehow they've discovered galaxies that have no dark matter. I've read
That's
that.
because they've got the supersonic wind, if you will, in space that blew the baryonic matter away from the
Dark
dark
matter.
matter.
Yeah. Yeah, there were a couple of very important epiphanies to that. I'm going to watch that talk again. She's very good.
Yeah, those dwarf galaxies are basically those ghosts that she was talking about.
Yeah.
Oh, not our orbiting local group. Magellanic clouds and things
No,
like
those are similar, yes. Well, although those seem to have dark matter, but there are some of the dwarf galaxies that don't show much dark matter.
that. Wow. It's amazing.
Or none.
Yeah.
I just learned a new term about black holes in a special nova I watched on PBS. The late Stephen Hawking's
Yeah.
said that black holes are slowly melting away. They have like
Evaporating.
They evaporate.
and it's called Hawking radiation or something.
Yeah.
Yes.
And black hole has sort of like a temperature, and yet they say nothing can leave it. Well, hell, that throws
No,
off-
but technically nothing left it. It's a matter dark matter, or excuse me, a matter antimatter pair.
Yeah.
And
It's a quantum effect.
right, and it carries energy away from the black hole.
Gotcha.
So it's going to take
Time for the big black holes to evaporate through Hawking radiation is many times the age of the universe.
Well, I think it's going to define the age of the universe.
Well, black holes may end up sucking up everything, and then everything will leak out. It'll be a dark place.
Well, yeah.
Except it's expanding faster than the speed of light, and that stuff gets flung away.
I guess.
Pretty soon it'll be a dark universe. Not pretty soon, but in eons.
Yeah.
Are any of you gentlemen going out to look at Saturn? It's nearing opposition, and I'd love some clarification on the rings and the moons.
We've been showing it at outreaches.
What?
Saturn was very visible last night, like 2 a.m. I mean, it was up high in the sky and clear.
Yeah, it's up by 9 or 10 o'clock, enough to show people at like Kachuma on Saturday.
Okay, 15 degrees high in the southeast sky, about an hour and a half after midnight.
No,
Jupiter
after
is
sunset,
up, too.
probably.
It's the brightest thing up there.
Okay, are we?
Outside of the moon.
I got kind of confused on Iapetus versus Enceladus or Enceladus. Which one was discovered by Herschel? Has white and black.
Oh, that was.
That wasn't Herschel. That was Cassini, I think.
Yeah.
Was it? Okay. Well, William Herschel's mentioned 1789.
Well, that's probably Enceladus.
That was Enceladus. So we're talking about Iapetus. Iapetus?
Yes. The one that's shown here, the
Okay.
walnut moon with the rib around the center.
Oh,
And the moon is white, mostly probably ice. And then it's got this black crap all over the front end of it. And that's why it stood out, was that he could see it sometimes and he couldn't see it other times because it had its black face to us or its white face. So its brightness changed. He didn't know why, but now we've flown by it and we can see why.
well, is it tidally locked? Is the dark part, the
Yes.
black, totally on the other side, or?
Yeah.
Yes.
It is. Well,
And that's why it's not uniformly covered with the material. If it were rotating, it would be uniformly covered.
Yeah, it's covered with these polycyclic aromatic hydrocarbons, which are darkish like barbecue gunk. And there seems to be a large cloud of that around Saturn, because one of the moons they saw with Cassini on the way in is Phoebe. And when they took spectra of that, they saw these polycyclic aromatic hydrocarbons all over that. So the leading edge of this moon in its orbit is getting spattered with this stuff. And the other side is fairly clear of it.
And the stuff comes from the planet?
From the other moon.
From some other moon that broke up, or from other stuff out there, just, you know, leftover stuff from the formation of the solar system.
Because if it's circling, it gets sun all over it, just like our moon does, even though our moon is tidally locked. So
yeah,
it's not tidally locked to the sun.
Yeah, right. So it just happened to be a coincidence that the part that's always facing Saturn is white?
No, the part that's always facing away from its direction of travel around Saturn is white.
It's like following a garbage truck down the street and it's got crap leaking out of it and it's spattering all over the front of your car.
That's the only moon in the solar system that does that?
They all do it, but this one has highly visible crap on it.
And then that ridge around the equator is actually very high, very tall. And one explanation I've heard is that potentially, you know, you see some large impacts here, that it had a large sort of submoon form around it that stayed close and broke up. And so the debris fell continuously like a ring falling down into this moon and distributed itself right along the equator.
So we're talking about a mountain ridge that's on its equator?
Yes.
Wow.
I thought it was a compression fracture from the big things that hit it above it.
That's an alternate explanation for that too. But which one it is, don't know. But if the thing were molten at one point and then solidified, then it would have shrunk. And depending on how it cooled off, this is the compression ring where the surface got tried to fit on a smaller object.
Looks like a walnut in space.
Yeah. Now the other moon, which I picked out, is this one, Enceladus, which is the clearest picture taken of Enceladus. It's a tiny moon compared to, although it looks big here, compared to our moon. But it's very obviously an ice surface. These are folds and things from the glacier, you might say, being tidally distorted around because it's following Saturn. These craters here, where they have this smoothish dome on it, is things that you see a lot on places where there's ice on top of liquid water. And this is believed to have liquid water underneath of it. It doesn't show the red bands of another moon. I forget the name of that moon.
Europa.
Thank you, Europa.
Yeah.
But we do have a lot of blue and greenish structure coming up.
These were called tiger stripes when they first saw them.
Mm-hmm.
Europa's around Jupiter, isn't it?
Yes.
The one we're looking at is around Saturn.
These two are Saturn moons.
Yeah, okay. Those aren't
Not the biggest one. The easiest one to see, obviously, around Saturn is a tiny red dot, Titan, which has an atmosphere that's very thicker than Earth's.
Yeah, this one is only like 250 miles across.
Yeah, this is a very small one.
We're looking at a big ice shell, right? A big egg made of frozen water.
Yes.
Well, liquid water with frozen water on the surface of it.
Yeah.
Or potentially just pockets of liquid water underneath in some places. And then they think it has a silicate core, you know, a hot core, because they managed to take the Cassini spacecraft. This thing has geysers that come out, like water ice volcanoes, cryovolcanoes. And they flew the Cassini spacecraft through some of the plumes. And what they detected was salts in the water, and also silicate material that hints that it may have a warm core in there also.
Well, if we ever decide to land on it, we don't dare use a rocket that has a hot flame, do we?
Someday there will be a Howard Johnson's on this.
All right, maybe little squirrely microorganisms underneath. That's fascinating stuff. It's got Mars canals on it too. Look at that son of a gun.
No canals.
before we go, it's now been an hour. Chuck McPartland, our outrageously outreachable outreach coordinator. What's outreachable soon that we're doing?
Tonight is Science Pub at Dargan's. I'm going to give a talk on meteorites, rocks from space. Wednesday is going to be Carpinteria State Beach. We'll have telescopes there and a slideshow. Friday is Refugio State Beach. We'll have telescopes there. And then Saturday is going to be the second Saturday Star Party at the museum.
Preceded by a 6 o'clock board meeting, not 6:30, right?
That's correct.
For the gentleman that might not know. Well, thank you all for joining us. I learned a lot. I hope I remember it. We'll talk again in a week after we meet in person. And Tom and Bruce and Jerry and Chuck, give my love to your wives and stay safe. Keep your masks on when you're out with real people. We'll see you in a week.
See ya.
Bye-bye.